For our second lesson in chemistry, we're going to take a more in depth look on the nature of matter. So, in our last lesson, we reviewed the definition of matter, the three types of matter, and then we looked at the particle theory of matter to try to help us understand the way that particles within matter move and exist and behave. Today, we're going to take all that matter that exists on Earth and we're going to try to organize it into some different groups. So, take a second here and look at these different images and consider which one doesn't belong. I'll let you stop the video right now, read through as a group each of these descriptions, and then together as a class, have a discussion as to which one do you think doesn't belong. Remember, sometimes there's more than one answer. When you're done discussing, hit play and keep listening to the lesson. So let's review what we learned about matter the other day in class. So just recall the definition of matter. This is anything that has mass and takes up space. And since matter makes up every single thing in the world or on Earth, we need a decent system that's going to help us group or classify all of the different kinds of matter that exist. We kind of have one grouping because we'll organize matter based on state. So we'll talk about it in terms of solid, liquid, gas, but we even need a better organizational system than just the three states of matter. So there are two subclasses of matter. There are pure substances, and these pure substances contain only one type of matter that has constant properties. And then there's a mixture, and a mixture contains two or more types of matter, and each keeps its own properties. So these definitions are at the top of your note. And now what we'll do is we're going to go into these two different categories of matter, and we're going to talk about them in more detail. So you have a chart on your note, and I want you to take a second and fill in the note with these titles. But just listen first. You have to leave spaces underneath the titles because we're going to add in definitions of what each of these terms actually mean. So take a second and fill in your classification of matter chart. But again, leave space. These are the titles, and then leave space so that we can fill in definitions for each of those. Stop the video and do this. So as we look at this chart, we notice that matter, which makes up everything in the world, can be organized into two categories, as we already mentioned, pure substances and then mixtures. Pure substances can be further organized or further classified into two groups called elements and compounds. And then mixtures can also be grouped into two different subcategories of solutions and mechanical mixtures. So what we're going to do now is we're going to go through the definitions of each of these. And then on this chart in your note, you're going to add in definitions here beneath each of these titles. So here is pure substance. And I know you have the definition at the top of your note, but I want you to fill this in the box in the chart. So a pure substance is that all particles of the substance have the same fixed structure. Okay, so same fixed structure. And that means that the particles within that pure substance are always exactly the same. Okay, and they're always present in the same proportion. So go down to the elements box and write in this definition. Elements are composed of one type of atom. So elements are actually the simplest form of matter that we have. And here's an example over here of an element. So what you'll notice is that there are these little green atoms that make up the element. And all those atoms are the same. You can see that they're green and you can see that they have an X in them. and they're all exactly the same. And there's only one kind. Okay, so elements only have one type of atom. They are the simplest form of matter. The other group of a pure substance is compounds. And so compounds are composed of different atoms. So if over here we look, we can see that we have now some green atoms, but we also have some purple atoms. And what you'll notice is that even though they're composed of different atoms, they're present in the same proportion. So for every purple, I have a green. Okay, for every purple, I have another green. For every purple, I have a green. And that pattern or that ratio, so in this ratio, I have one purple to one green, is constant and it never ever changes. So compounds exist when different elements basically make up the compound. And sometimes it's, one purple, one green. Sometimes it might be like two purple for every green. It all depends. It's different for all of them. But it's always the same fixed structure throughout the entire type of matter. If we have a mixture, which is on the other side of the chart, jot this definition in the box that is there. So mixtures contain different pure substances. So if you have a mixture of matter, then you're going to have a combination of elements and compounds. Maybe you have a combination of a couple of elements. So I think of steel. Okay, so steel is a mixture because it's composed of iron and carbon. Those are both elements, and they're mixed together. Maybe you'll have a mixture that is like salt water, and it contains salts, which is a compound, and water, which is a compound. But they're different, pure substances. They're mixed together. They'd be classed as a mixture. So there are two kinds of mixtures that we can have. One is a solution. And the definition of a solution is that the parts of your mixture are uniformly mixed. Okay, so that means that you don't see the different parts that are there. When you don't see the different parts, we call that one phase. And this is the other word we use. We use the term homogeneous or homogeneous. Sometimes it's pronounced either way. And those terms tell us that everything is mixed or blended together. So here's an example over here. Here's cranberry juice. So we would look at cranberry juice, and that is a solution because we don't see the water. We don't see the actual cranberry parts. There's probably sugar in there. We don't see the sugar. Everything blends together, and we only see one phase. A mechanical mixture is the other type of mixture you can have, and this is where all the parts are visible. So the different pure substances that make up the mixture, you can see them, and we say that's more than one phase. The other term we use is heterogeneous. So heterogeneous means that you can see all the different parts. And here's an example over here. I know the picture's small, but that looks to me like some sort of like bread, like a loaf or some cake. And I think there's nuts on the top and it's chocolate, and there's maybe chocolate chips. And you can see the different parts that are in there. Some are blended, okay, but you can see different parts. And so we call that a mechanical mixture. So again, solution means that everything's mixed together. We also will use the term homogeneous for that. So it'll go by two names. And then mechanical mixture, you can see different parts, and we say heterogeneous for that. Okay. Here's an overview of our classification. Okay, so again, you've got this all down. And what's even better is you have a definition now beneath each of these terms for our different groups of matter. So matter can be grouped into pure substances or mixtures. Pure substances have a fixed structure or a fixed composition. Elements have one type of atom. So when we look at this diagram, we just see purple atoms. They all look the same. Simplest form, the element. A compound will have different atoms of elements put together in a fixed structure. So take a look at this. This has one red atom with two blue atoms, and they all look exactly the same. So this would be a compound because you have different atoms making up an entire type of matter. Mixtures can either be homogeneous or solutions, or heterogeneous and mechanical mixtures. If it's homogeneous and a solution, that means it's a blend of pure substances. So they're showing you here some purple atoms, and they're showing you some other compound. This is a type of compound because there's two different atoms bonded in. And when we see them all mixed up like this, we know everything is blended together. We can't see the different parts. There's only one phase. A heterogeneous mixture is also called a mechanical mixture. And this is where you'll have, again, pure substances combined, but you can see them, okay? They don't blend. And this image is showing you that. They're showing you that all the purple atoms are together and all these other compounds are together and they're not mixing, okay? They're not moving, past each other. So this would be a mechanical mixture as well. So let's classify the matter type. So if I see this chocolate chip cookie, which type of matter? And think of either element, compound, solution, or mechanical mixture. Stop the video, take a guess, and then resume the video to hear your answer. Okay, so this chocolate chip cookie, because we can see different parts of it, this would be called a mechanical mixture or a heterogeneous mixture. Here's another. So what type of matter is this? Is this an element or a compound, a solution, or a mechanical mixture? And so what we see that this is oxygen. We see two red atoms bonded together. We assume that these atoms are the same. So if everything is the same, what kind of matter? This is an element, okay, made of the same type of atom. This is vanilla ice cream. So if you're looking at vanilla ice cream, what kind of matter is that? So again, is it an element or a compound, a solution, or a mechanical mixture? And vanilla ice cream would be a solution or homogeneous. There's lots of stuff blended together in vanilla ice cream. There's milk and ice and sugar and vanilla flavoring, and we don't see it. Okay, it's all blended together. There's one phase in there. And then lastly, what type of matter would table salt be? So table salt is called sodium chloride. That is its chemical name. And it's made up of a sodium atom and a chlorine atom. Now, you don't see that. When you look at salt at home, it's just white, right? Crystally, granular. We don't see what gets made up within the salt substance. But if we look at a molecular level, we can see that it's got different atoms in it. And they all look the same and they look to be in the same proportion. So what type of matter would salt be? Well, element, compound, solution, or mechanical mixture. And the answer is compound. Okay, you're going to stop the video now, and in your booklets, you have this worksheet to work on, and then you have this one here. So you'll notice, again, particle diagrams, right? And from there, you can classify your matter, and then one more worksheet left at the end.